Welcome to Module 15 of our complete structural design course for one-story building. Today we want to learn how to prepare bar bending schedule, and our focus will be on column, bases, and column. I want to use this privilege to sincerely appreciate those that have purchased our online courses. Thank you very much. God bless you. And I want to also use this privilege to encourage those who have not yet purchased our online courses on reinforced concrete design to feel free to contact us and do so. When you purchase the course, you will have a direct one-on-one mentorship. We will add you up to our masterclass WhatsApp group where you will learn a complete design of reinforced concrete and steel structures. Thank you. God bless you. Okay, so before we go into the practical demonstration of how to prepare bar bending schedule, let us first and foremost look at what bar bending schedule is. Okay, so what is bar bending schedule? We say here that it is a structural information document that presents the list of structural members, size and type of reinforcement, numbers of rebar in each member, shape of rebar, diameter of rebar, cut length, total length, and location of all reinforcement in the construction drawing. So bar bending schedule give you a tabular form of list of information about the reinforcement of a particular project. It gives you the information about the location of the structural members, the size of the structural members, the length. Sometimes you find it difficult to calculate the length of the rebar in the working drawing. By the time you go to the bar bending schedule, you will now see the accurate length of that rebar. So that is what bar bending schedule does, giving you information about the reinforcement in a particular project. Now, what are the benefits of bar bending schedule? It helps steel benders to accurately identify the shape, size, and length of rebar in a construction drawing. It also helps quantity surveyors and even cost engineers in preparing bill of quantities in a project. It helps contractors and construction experts to know the correct length of structural member in a particular location. Then lastly, it gives a summary of the reinforcement quantity in a particular project. So I think with these few information that we have about bar bending schedule, so by the time we go into the practical preparation of bar bending schedule, you really appreciate what we have just said. So let's just go into the practical environment. Okay, so our focus will be on column, bases, and column. So this is column base type 1, and it has 24 number doors. Then each of these footing reinforcement is 7 wide, 1201. Then we also have 7 wide, 1201 here. Now while we have the same bar mark, is because we have the same size of footings. You look at the LY. The LY is 1,300 and the LX is 1,300. So we will have the same length of the reinforcement and also the same diameter of the reinforcement. Now, these seven actually tells you the numbers of reinforcement that is on this direction. Then the Y is actually the type of steel. You know that we have different type of steel. We have high yield steel. We have a mild steel. So this Y denotes high yield steel. Then the 12 here is actually the diameter of the reinforcement. Now the O1 is the bar mark. O1 is the bar mark. Now this bar mark is used for reinforcement identification. So the moment you see O1 will tell you the diameter of the reinforcement, the shape of the rebar, the length of that rebar. Then this 200 is actually the spacing of the reinforcement, that you have to space this reinforcement at 200 center to center. Okay, so this is how a typical bar bending schedule look like. So we are going to take the bar bending right now. So here we have column type 1. We have column type 1. So the first thing in our table is location. Remember, in our definition we mentioned location. That is help us to identify the location of the structural member. So here is what it does, the location, and the location here is column base type 1. So mark, we have O1. This is the O1 that we have. Then the next one is number doors. Now number doors simply means the total number of this column type 1 in the project. The total number of this column type 1 in the project. Then immediately after that we move to number in each door. Now number in each doors simply means number in each of the column base type 1. Remember that we have about 26 of it. So number in each of these is what number does mean. So in this case, our number in each of these is 14 when you add 7 and this other 7, so you have 14. So here we have 14. The number does is 26. Then the bar size is Y12. Then total length, we have total length by multiplying 26 by 14. So when you multiply 26 by 14, you have 364. So the next one is for us to calculate the shape. So here we have the shape of the reinforcement. If you pick this reinforcement out from here, this is how the shape look like. Okay, so we have to represent it here. Okay, so from here to here we have 120. How do we have the 120? Now when you look at the entire reinforcement, the entire column base, it is 1,300. Now cover the footings is 50. So we subtract 50 from the right hand side and 50 from the left hand side. So when you subtract 100, that is 50, 50, you have 100. And when you subtract that 100 from 1,300, you have 1,200. Then this other one is the bend up bar, and the length of it is usually 150. That is 6 inches. 6 inches. So when you add this 150 to 1,200, then add this 150 again, you have 1,200. 500. Now, for us to have the total quantity, so for us to have the total quantity of the reinforcement, we simply multiply 364 by 1500. So let's do that. 364 times 1500. So we have okay, let's break this. Let us make this in meter. So let's make this in meter. Okay, so we divide this by 1000. So this will give us 546 meter. 546 meter. So we have to specify so that the person will know, whoever that will interpret the design will know that it is in meter, and also because of the space. So this is in meter. Okay, so we are done with column based type 1. Column based type 1. Then we move to column based type 2. Column based type 2. Column based type 2. So the bar mark here is O2. So let's look at O2. Okay, so these are O2. These are O2. So the O2 has a diameter of 12 mm. O2 has a diameter of 12 mm. Diameter of 12 mm. Diameter of 12 mm. Okay. So number in each. Number does is 6. Number does is 6. Now number in each is 8. Number in each is 8. Now I want to understand that this reinforcement is top and bottom. So what we do is we multiply this by 2. So this will give us 2 times 8. 2 times 8. So here we will have 16. Here will be 16. Okay, so 16 times 6 times, so that will give us 96. So this will give us 96. Okay, 96. So what is the shape? So this is the shape of the reinforcement. So as you can see, from here to here is 1000. So applying the 50 mm cover, so this, by the time you subtract the 100 from 1000, we will be left with 900. That's why we have this 900. Then our normal paint up bar is 150. So by the time you add this up, you will have 1200. So the total quantity here in meter will be 96 times 1200 divided by 1000. So this will give us 115.2 meter. 115.2 are done with O2. So we move to O3. We move to O3. So O3 has the same diameter of reinforcement, which is Y12. Y12. Then the same number does. But here we have number in each. Remember that it is top and bottom. So this will be 2 times 5. 2 times 5. So 2 times 5 will give us 10. So here we have 10. We have 10. So when you multiply 10 by 6, you will have 60. You will have 60. Okay. So let's look at the shape. This is the shape of O3. So the same shape, but the length is from here to here, which is 1600. So you subtract 100 from it. When you subtract 100 from it, you will have 1500. So that is why we have the 1500 here. When you add up these bends up back, you have 1800. So total quantity will be 60 times 1800. So 60 times 1800. So we divide that by 1000. So we have 108 meter. So we are done with column base type 1 and column base type 2. So we will consider column type 1. We will consider column type 1. Consider column type 1. So this is the column type 1. So the first thing we will calculate in this column type 1 is the link. So you have to calculate the link, and the link size is diameter 8. The link size is diameter 8. So we have that. Then number does is 34. Number does is 34. That is why we have the 34 here. The number in each of this. Now since we are considering the stirrup, so we are going to add up everything. So when you add 9 plus the 12 plus 18, 9 plus 12 plus 18, that will give us 34. So number in each is 34. So you multiply 34 by 34, you will have 1156. Okay, 1156. Then we calculate the shape, the cut length of the stirrup. Now let's go back. Now the column cover is 40. There are people that do take 80, but the code specify 40. So the column cover is 40, and we have the total size of the column to be 225. So when you subtract 80 from 225, you have 145. So, and it is a square column, so that will be 145 times 4. 145 times 4. Then this bar here is a kind of overlap bar. It's overlap. Now when you cut this, you must have a surplus where this one will now overlap to this, and this one will overlap to this point. Now for the sake of detailing, we have to bring it up the way it is, and it is usually 50. So when you add 50 plus 50, you will have 100. So 145 times 4, 145 times 4 will give us 580 plus 100. We will have 680. Okay, so 680, for us to calculate the total quantity of this reinforcement, this stirrup reinforcement, we have to multiply the cut length, which we have just finished calculating, for one of it by the total number of that reinforcement. So this will give us, this will be 1156 times 680. So you divide this by 1000 to convert it to meter. So this will give us 84 times 84. Okay, fine. Okay, so we multiply this by 680. Okay, we divide this by 1000. Okay, so this will give us 786. Now for you to know the actual length of this Y8, you simply divide this by 12. That is the standard length of the reinforcement. So at the end of the day, you realize that you will have about 65 to 66 lengths of Y8. You need about 66 to 65 lengths of Y8 for you to produce the stirrup that you will use for about 84 numbers of this column. Okay. Then the next one is for us to calculate the main reinforcement of the column. So we have here 04, and 04 has Y16. 04, so the diameter of reinforcement here is Y16. Then the number does is 34. The number in each is 4. Number in each is 4, as you can see here. Number in each is 4. So 4 times 34 will give us 136. So we want to calculate the shape of this. Now practically this starter bar is always straight. Except in a very rare occasion where you have to bend it the way it is. But the reason why we have to bring it this way or present this shape as it is to enable us calculate accurately the length of this bar. So here you have, from, this is the DPC, we have the oversized concrete, we have 150 hardcore, and below here you have the earth filling, the earth that is laterite. So we said that from here to this place is about 1,500, excluding blinding, So we want to calculate this, the length of this reinforcement now. Remember that we have our footing reinforcement, which is, we have the first 12, then you have the second layer, which is also 12. So by the time you add the two, you will have 24. So this starter bar sits on the second layer of it, but our depth is 1,500. So for you to calculate the length of this bar from here to this point, you have to subtract 24 from 1,500. So when you do that, you have 1,476. So that is why we have 1,476. Then this bend, this L length is usually between 250 200, but you must do it in such a way that it will sit on this layer of this footing reinforcement. It will sit properly. So you can adopt 250, you can equally adopt 200. So in our case we adopted 200. Okay, so that's how we got this 200. Then let's get this here. From here to here is 300. So we have to represent it this way so that we can show you, so that when we are calculating the length we will not make mistakes. So here we have the 300. Then immediately after the 300, above the DPC level, there must be a 750 projection, and it is called lap length, so that when the continuation bar comes in, it will lap, you will tight it onto this 750 lap length. So the lap length should not be less than 750. It should not be less than 750. So that is why we have this 750. So by the time you add up 750 to 300 to 1,476 to this. So let's add it up again. 200 plus 1,476 plus 300 plus 750. So we have 2726. We have 2726. We have 2726. So for us to calculate the total quantity of the reinforcement, so we multiply this by 136. So multiply this by 136. So we divide by 1000 to convert it to meter. So we will have 370. So we can convert this to 371 meter. 371 meter. So 371 meter. Then the next reinforcement that we are going to consider will be 05. The same number, which is 4 y 16. So 04, 05. The same number does the same number in each. Then when you calculate, you have 1 3 this. So let's look at how we calculate this. So from here, this is our lap length, which is the 750. So from here to here is at 3000. Remember, this is the beam, the floor beam. So it's at 3000. So this reinforcement will move straight from the DPC level to the first floor, and you will have to project 750 again as the lap length. So when you add this 3000 to this 150, you have 3150, then plus 750 plus 750. So that is why we have this 3000. This is the 150, which is the slab thickness. This is the 750. So when you add it up, you have 3900. So for us to get the total quantity of this reinforcement here, we multiply this by 136. So 136 times 3900. So we divide by 1000. Okay, so this gives us 5. It gives us 5 3 0. So we can add 1 to it because of surplus. Okay, wastage. Okay, so the next one is 06, and 06, the diameter of 06 is 12. The diameter of 06 is 12. Diameter of 06 is 12. Then the same number does. Then the same number in each. So when you calculate this, you have this. So let's calculate 06. Now we have here to here is about 3 meter. This is the roof B. This is the roof B. So from here we have 2500. So what we simply do is to add this to this, which will give us 3000. Then we have this other beam bar that is 50. So okay, so from here to this point, we may take between 25-30 as the cover, because there must be a cover here. So you cannot hit this reinforcement directly on this formwork. So you have to subtract your cover. So we assume that our cover from here to here is 30. So when you subtract 30 from 3000, you will have 2970. Then this one is 50. So when you add it up, you have 3020. So for us to get total quantity of reinforcement for the first floor column, we have to multiply this by this. So this will be 136 times 3020. So this gives us, we divide this by 1000. Okay, so this will give us 40. So we can pick 4. We can pick 412. No, 411. As so we are done with taking bar bending for column basis and column. So we will stop the video here so that it will not be too long. So in our next model, we will consider taking bar bending for slab. I believe that you have learned something, and if you have any comments, just feel free to drop it in the comment box. And I want to also use this privilege to encourage those that have not yet subscribed to our YouTube channel to do so that when we upload a new video, you will be the first to be notified. Thank you very much. I appreciate those that have actually watched our videos, our viewers. I sincerely appreciate you. Those who have subscribed to our YouTube channel, thank you very much. All the people that have comments on our videos, I want to sincerely appreciate you. Thank you. You are the reason why I am doing this. Thank you very much. God will bless you, and I promise you that I will continue to produce more video in structural civil engineering profession, so that all of us can learn and grow together in this profession. Thank you. God bless you. See you in model 16.